Okay, in this one, it says find the indicated area of each pyramid to the nearest whole number. And so in example 1, it says find the lateral area. So remember with me, friends, that the surface area formula is 1/2 perimeter of the base times slant height plus area of the base. And when you're talking about lateral area, you're talking about just the first half of that formula, just the part without the base. So you're really just talking about 1/2 perimeter of the base times the slant height. So in this first example, we see that we have a square base with 16 for each side. And then we also have the actual height coming down the middle. The altitude is what that is the 15. And what we don't know is the slant height. So you have to draw in your very own slant height that goes from the top to the bottom rim of that square. And keep in mind, you don't have to draw it there. If you want to draw it over here and then connect it, or wherever you want to draw it, it doesn't matter. It just needs to be, your slant height has to go down the middle of one of those side triangles on the pyramid, and then it should be perpendicular to the base. And when you do that, that conveniently forms this right triangle here, which is the key to finding the slant height. Okay, so our slant height is L. And then we also know that if it's 16 feet across, so I'm starting this problem, I'm aware we could go ahead and do this part, but I'm starting this problem by finding that slant height that we don't know. And so we know that if it's 16 feet all the way across the square, then halfway across would be 8. And so we go to our side work and do a squared plus b squared equals c squared. And so 8 squared plus 15 squared equals c squared equals, in this case, L, our slant height, squared. So this is a triple. I'm not sure if you know this one, but this is an 8, 15, 17. So our slant height comes out to be 17. And now we're ready to find the whole lateral area. So we're going to say 1/2 times perimeter of the base, we know means the distance around the base. So I've got 16 plus 16 plus 16 plus 16. In other words, I've got 4 16s. I'm going to call that 16 times 4 sides. And then our slant height we figured out was 17. Okay, and so that comes out in my calculator to be approximately 544 feet squared. So just want to point out that this is still feet squared. This is still area. It's just the area of the side triangles, and it doesn't include the square base. But because it's still area, it's still feet squared. So we could find the surface area of this problem. We would just find the area of the base and then add that to it. But that's not what they asked for. So we're going to go on then to the second problem here. And on this one, they ask us to find the surface area. So we're going to do the full formula this time. The 1/2 times P times L plus the area of the base. So I want you to take a look at this picture over here, and I want you to just notice. What do you notice is given to us? What do we have to work with? So this looks like we have each side length. We know all the sides are the same, are going to be 3.2. I'm also noticing that there are 6 sides. 1, 2, 3, 4, 5, 6 sides. That's a hexagon. I'm also noticing that this 10 over here is going down the side. It's slanty, and so that's my L, that's my slant height. I'm also noticing that I have the height drawn in, But you know what? This time I don't need to make that triangle. I don't need to solve for the height because this problem, nowhere in this formula does it actually ask for the height. We will need the actual height when we go to do volume, but for now we do not. All right, so this is the information we have to work with. So I have 1/2. Perimeter of the base is what P stands for, times L, which stands for slant height, plus the area of the base. Okay, so let's just go through and make sure we all understand what's going on here. We have P, which stands for perimeter of the base. We have L, which stands for slant height. We have B, which stands for area of the base. So these are the components of our formula. So let's plug in what we can find. If I want to find the distance around, the rim, the word rim is actually in the word perimeter. We're going to have 1/2 times, I've got 3.2 for each side, and there are 6 of those sides. So I could say 3.2 plus 3.2 plus 3.2 plus 3.2 plus 3.2. I can do that 6 times, or I can just say times 6. Then my slant height is the 10. So just to be clear, this is the slant height. This is the perimeter of the base. Plus, here comes the hard part, area of the base. Now, you have to think about, in order to do the area of the base, what shape is my base? And so we know that this shape on the bottom of this pyramid is a hexagon. It's what we call a regular polygon. Regular because all the sides are equal. Polygon. And so because it's a regular polygon, we would go look at our area sheet, and the formula for a regular polygon would be 1/2 AP. 1/2, you know what, I'm going to write that out. That's apothem times perimeter. And that's what this area of the base is. All right. So I'm going to tell you what, I'm going to go ahead and put all this in my calculator just to make it a little bit more concise, give me a little bit more room. So 1/2 times, so I'm putting in my calculator 0.5 because that's the same thing as 1/2, times 3.2 times 6 times 10 comes out to 96 for that part of the problem. Plus, for my area of the base, 1/2, don't know my apothem yet. But what I do know is that my perimeter, we already found that, the perimeter of the hexagon, the perimeter of the base, is 3.2 times 6 sides. So to find that apothem, guys, it's that same hexagon that keeps coming back. So we have, here's my apothem. It goes from here. So this is just the base of the pyramid is what this blue part is right here. On the base of my pyramid, I know that each side is 3.2. And I need to know the apothem in order to solve this area of the base problem. So here's my apothem A. So the key to this problem is if I can just figure out this angle here, then I have enough information to figure out how much A is. And so our strategy for that is we split this triangle up into 6 big triangles. How did you know it was 6 triangles, Miss Benton? Well, there's 6 sides, and the number of interior big triangles is always the same as the number of sides. So we know that all of these angles combined in the middle add up to 360 degrees. So if we take that and divide it by 6 central angles, each one will be 60 degrees. So then that apothem going down the middle of that 60-degree angle is going to split that into 30 and 30. So now I have a 30, 60, 90 triangle. I know that 3.2 is a whole side, so the bottom of the yellow triangle is 3.2 divided by 2, so that's 1.6. And on a 30, 60, 90 triangle, if across from 30 is 1.6, across from 60, my apothem will be 1.6 square root 3. So we had to use our 30, 60, 90 skills to figure that out. So now it's just a matter of putting this all in your calculator. 96 plus 1/2 times 1.6 square root 3 times 3.2 times 6. So let's go put that in our calculator. Okay, so we're looking at 96. I'm going to put this all in my calculator, all in one fell swoop, plus 1/2, which I'm just going to call 0.5, times 1.6 square root 3 times 3.2 times 6. Oh, I've got 3.22. I've got 2 2's in there. All right, which I'm getting to come out to be 122.6. And that is my surface area.